Okay, so let's ask similar questions to what we've been asking. We have a sequence. We want to know if it's bounded, monotonic, and what's the limit. And so, as before, let's start with the monotonic question. F at x would be tan inverse of x over 5x, and let's take its derivative. Using the quotient rule, we get the bottom times the derivative of the top. Derivative of tan inverse is 1 over 1 plus x squared plus the top times the derivative of the bottom, which is 5 all over the bottom squared. Again, an entire denominator is positive, so I can ignore it. The numerator becomes 5x over 1 plus x squared plus 5 times tan inverse of x. Now, x is positive because we're looking at x as a placeholder for n. So these are always positive. Right? So this is always positive. The problem is the tan inverse, and what about tan inverse? Tan inverse, let's remember what tan inverse looks like. Tan inverse actually looks like this. It's tangent is kind of like an S-curve bounded by negative pi over 2 and pi over 2. Tan inverse will look like this, bounded below by negative pi over 2 and above by pi over 2. But if I only have positive values of x, because we only have positive values of n, this is positive. So this is positive. Everything in here is positive. Which means that this is, f prime at x is always positive, at least for x positive, so that this is monotonically increasing. What is the limit as n goes to infinity? And is it bounded? Let's keep this while I redraw my picture. This tan inverse picture is important, an important part of this. Remember that I have minus pi over 2, I have positive pi over 2, and tan inverse is bounded by those as drawn here. So this is tan inverse of x. So that means that the numerator is actually bounded. The numerator, the biggest value that this numerator is going to get to is pi over 2. The denominator is getting bigger and bigger and bigger. Right, so I have the numerator, in the end, the biggest this can be is pi over 2, but the denominator goes all the way to infinity. So it's like pi over 2 over infinity, which will end up being 0. But the point is that, yes, this is bounded. This does not go up to infinity because the denominator goes to infinity, the numerator is stuck. So it's not going up anywhere. We decided that it was monotonically increasing, but it is bounded as well. And the limit, as n goes to infinity, of tan inverse of n over 5n. Well, this is bounded by pi over 2, and this goes to infinity. So it's like a constant over infinity, so that limit is 0.